Hello dear, how are you all? Today in this video we are going to start Excel 1.1 question 3. The perimeter of scale as a function of its area. You know, dependent variable is always function of independent variable. Here in this problem, perimeter of scale, we draw first scale and then find perimeter of scale. Perimeter of scale means length of its boundary wall. To calculate perimeter of scale, perimeter of scale will be equal to 4 multiply one side or sum of all sides. 4 multiply one side. That is P is equal to 4 multiply one side. We take its side as small a. Small a consider the length of side of a scale. Then perimeter of scale P is equal to 4 times of a. This is the relation 1. And we know have to find area of scale. You know, area of scale is equal to side multiply side. Area of scale will be equal to side multiply side. Area of A multiply A, which is equal to A scale. We write area of scale, which is A scale. This is the relation 2. Now we have to show that perimeter P as a function of its area. You know, dependent variable in this problem, perimeter of scale is a dependent which depend on the area of scale. As we increase area, its perimeter also increase. By decreasing its area, perimeter will also be decreased. We have to show that P is the function of its area. P is the function of its area. We have to find such type of relation. P is equal to something of A. P is equal to function of A. From relation 1 and 2, we just have to eliminate A. From equation 2, we write from equation 2. From equation 2, A small a, value of small a is equal to under root a. Under root a. Put it in relation 1. Put it in relation 1. 1 implies that P is equal to 4 times of value of a, which is under root a. This will be the relation between perimeter and area of scale. We show that perimeter of scale is a function of its area. In second example, we have to show that circumference of a circle. We have to show that area of circle as a function of its circumference. We will solve second part of question 3. In second part, we have to show that area of circle as a function of its circumference. We have to show that area of circle as the function of its circumference. Area of circle as a function of its circumference. We consider a circle having the radius r. The question is this, problem is this. We have to show that area of circle as a function of its circumference. Its solution we write, consider a circle circle of radius r. This is a circle with radius r. You know area of circle? Area of circle will be equal to pi r square. This is relation 1. And circumference of length of its boundary wall. Circumference of circle, which is equal to 2 pi r. This is relation 2. We have to show that area of circle, A mean area of circle, which is equal to pi r square. This is relation 1. Circumference, if we denote circumference by c, we write c is equal to 2 pi r. This is relation 2. We have to show that area is the function of its circumference. We have to find such a relation. A is equal to f of c, mean area is the function of its circumference. We just have to eliminate r from 1 and 2. From equation 2, r will be equal to from 2 we write, from 2 r will be equal to c by 2 pi. We put the value of r is equal to c by 2 pi in relation 1. Put it in relation 1. 1 implies that A is equal to pi r square. R square means c by 2 pi whole square. C by 2 pi. C by 2 pi whole square. We write pi multiply c square by 4 pi square. We divide, we cancel pi by pi square. We will get c square by 4 pi, and we write A is equal to c square by 4 pi. This shows that area of circle is the function of its circumference. A is equal to c square by 4 pi. It is a relation between area and circumference of a circle. In example, in last part 3, third part, we have to show that, in part 3, we have to show that volume of sphere or volume of cube in part 3. In part 3, we have to show that volume of cube is a function of its volume of cube is a function of its area base. First we draw shape of cube. We can draw cube like this. This is the base of cube. I will try to show you by red line. These red lines show the base of this cube, and base of this cube is a scale, because in cube all dimensions are equal. We take this length as a length and this length we take as a width, and this length we take as a height. In a cube, you know that all sides are equal. We write, consider a cube of side small a. We write volume of cube. How can you find volume of cube? Volume of cube will be equal to length multiply width multiply height. Length multiply width multiply height. V stands for volume, and length, which is A, width, which is A, height, which is also A. Volume of cube will be equal to A cube. Cubic meter or cubic unit. Volume of cube, it is A cubic unit. We now have to find the area of its base. Its base will be scale. This side and this side make a scale. We write area of base. Area of base, which is equal to A multiply A, which is A scale. Capital A is equal to A scale, is relation 2, and B is equal to A cube, is relation 2. We have to show that volume of cube V is a function of its area of base. We have to show that volume of cube is a function of its area of its base. We have to show that V is equal to f of A. We just eliminate small a from relation 1 and 2. You know, from 2, small a will be equal to under root A. We put the value of small a, which is under root A, in equation 1. Put it in 1. 1 implies that V is equal to A. We replace small a by under root A and whole cube. After simplify, we multiply power A raised power 1 by 2 whole power 3. We write A whole power 3 by 2. Finally, we write A is equal to V is equal to A raised power 3 by 2. This is the relation between volume and area of its base. We show that volume of cube is a function of its base area. Thank you.